We've already talked about the sine and cosine curves and about amplitude and period. Now we're going to throw in phase shift. So the amplitude is still A, the number in front. The period is still 2 pi divided by B, the number in front of the X. And now the phase shift is C divided by B. And this is where y equals A times sine of bx minus c. So let's look at an example. The amplitude is the absolute value of the number in front, 3. The period is 2 pi over b, and b is 2. So 2 pi over b is 2 pi over 2, or pi. Now for the phase shift. The phase shift is C over B. That's pi over 3 divided by 2, or pi over 6. So how do we graph these things? We want to look at our 5 key points. Okay, so our 5 key points, if you'll remember, we take our period and divide by 4. So the period is pi over 4. So sine would normally start at 0, 0. And it's still going to. But then instead of going to pi over 2, it's going to pi over 4. And then let's think about the amplitude. Normally, our sine would go up to 1 here. But because the amplitude is 3, it's going up to 3. Pi over 4, add another pi over 4, we get pi over 2. And it goes back to 0. Add another pi over 4, that's 3 pi over 4. And we're going down to negative 3. And last, another pi over 4 takes us all the way to pi, our complete period, back to 0. Okay, so that is y equals 3 sine of 2x. But we need to take into account that minus pi over 3. So what we do is all of our x values, so I'm going to keep the y values, so let's just go ahead and write this down. All of our y value, or all of our x values, we're going to add pi over 4. Or excuse me, pi over 6. Okay. So 0 plus pi over 6 is pi over 6. Pi over 4 plus pi over 6. I'm not going to do this for all of them, just for this one. Let's see, common denominator would be 12. Give us 3 pi and 2 pi. So that would be 5 pi over 12. Add another pi over 6. We get 2 pi over 3. Another pi over 6 is 11 pi over 12. And then another is 7 pi over 6. So these are our 5 key points. And what we're going to take over here to graph. Okay, so we start with pi over 6, 0. There it is. Then we've got pi over 12, 3. Oh, that's a little bit hard to find. Let's skip to the next one. 2 pi over 3, 0 is right here. Then if we skip again, 7 pi over 3, is it 7 pi over 6? Here's 1, 2, 3, 4, 5, 6, 7. There it is. 7 pi over 6, 0. Yeah, now it's hard to find the ones in between unless you do it like this, okay? 5 pi over 12 is not marked on our graph, but we know it has to be halfway in between these two. So somewhere up here, about halfway in between, looks like about right there, we have the point 5 pi over 12, 3. And then, again, I don't like where I put that. I think it's more about right there. Yeah. And then about halfway between 2 pi over 3 and 7 pi over 6, we have our negative 3. And so, now we have our graph. There is one period of this graph. And we could go on from there, but we don't really have to. We want one period. Done. Okay. Cosine, same thing as sine, okay, except for it's moved over. So we still use an amplitude in A, our period is 2 pi over B, and the phase shift is C over B. Same as with sine. So with this function, our amplitude, the number in front, absolute value of 2, or 2. The period, 2 pi over B. And B in this case is negative 4. I don't like this. Let's go back and look at this for a minute. We don't want that negative to be right there. So what I'm going to do is I'm going to rewrite this. We can take if we multiply through by a negative, then negative 4x plus 3 pi is the same thing as 4x minus 3 pi. That's going to make things easier for us to talk about. Okay, now, so our period is 2 pi over B, which is 4. Reduce it, so our period is pi over 2. And then the phase shift is C over B. So our C is now positive 3, remember, opposite, over 4. Or positive 3 pi, actually. We include the whole thing. So the phase shift, C over B, is 3 pi over 4. Okay. So, next step, 5 key points. So we're talking about cosine. So normally cosine would start at 0, 1, right? Because the amplitude is 2, and it's a positive 2, then that means our y value will start at 2. Then it'll go to 0. Then it'll go to negative 2. Then back to 0. and then back up finally to 2 to complete one period. But we need to talk about, well, what are our x values? Take the period, divide by 4. So our period is pi over 2. Divide that by 4. And we have pi over 8. Okay? So, starting at 0, we want to go every pi over 8. So, we got 0, then we have pi over 8. 2 pi over 8 would be pi over 4. 3 pi over 8 would be 3 pi over 8. And then 4 pi over 8 is pi over 2. And then we need to take into account our phase shift. So our y values are staying the same again. And then the phase shift, we said, was 3 pi over 4. So we need to take each of our x values and add 3 pi over 4. So we've got 0 plus 3 pi over 4 is just 3 pi over 4. Pi over 8 plus 3 pi over 4 is 7 pi over 8. 7, then we take our pi over 4 up here and add pi over 8. Oh, I did something. That's not, I just wrote it wrong. So it was pi over 8. No, that was right. Okay. Then we've got pi over 4 plus pi over 8. That gives us pi. No. I'm losing myself here. Okay, so what we've got actually is we're adding pi over 8 to each previous one. So we added pi over 8 to 3 pi over 4 to get here. And then 7 pi over 8 plus pi over 8 gets us there, pi. Then pi plus pi over 8 is 9 pi over 8. And 9 pi over 8 plus pi over 8 is reduced 5 pi over 4. Now we've got our 5 key points, and we can graph. Okay, so 3 pi over 4, 2. And again, that in-between one's kind of hard, so let's not mess with this. Let's go to pi negative 2. And then up to 5 pi over 4, 2. So halfway between 3 pi over 4 and pi, we're going to be at 0. So there's our 7 pi over 8, 0. And then halfway between pi and 5 pi over 4, we're going to be at 0 again. So here is one period of our graph. Now I don't like to leave it hanging there in the middle, so I'm going to go on over, take it to 0. So we've got, we should have, that would be negative 2. And then pi over 4 will be back at 2. So And then here we'll be back at 2. There we go. Okay, let's look at a couple more examples. Same type deal, just working it several times to make sure you get the hang of it. Amplitude, the number in front. So absolute value of 3 over 2 is 3 over 2. The period is 2 pi over b. So 2 pi over 2. Period is pi. And then the phase shift is c over b. Notice the plus pi. Remember, we do the opposite. So c is negative pi. So that means c over b will be negative pi over 2. Now we talk about our 5 key points. So cosine normally starts at 0, 1. Since we've got a amplitude of 3/2, then that means it would start at 0, 3/2. Then it would go down to 0, then to negative 3/2, then to 0, and then back to 3/2. Okay? Put into play our period. The period over 4 gives us our 5 key points. So since our period is pi, then our 5 key points are going to be at every pi over 4. So we started at 0, and then pi over 4, add a pi over 4, and we get pi over 2. Add a pi over 4, you get 3 pi over 4. Add a pi over 4, we're at pi. And then take into account our phase shift. So again, I'm going to go through and just write down our y values. And so for our phase shift, we are moving to the left pi over 2. So all these numbers we need to subtract pi over 2. So 0 minus pi over 2 is negative pi over 2. Then we've got we go every pi over 4 from there. So negative pi over 2 plus pi over 4 is pi over 4. Pi over 2 plus pi over 4. Excuse me, back here that was supposed to be a negative pi over 4. Because we had pi over 4 plus negative pi over 2. Okay. So now, negative pi over 4 plus pi over 4 is 0. 0 plus pi over 4 is pi over 4. Pi over 4 plus pi over 4 is pi over 2. And now we can graph our 5 key points. So we got negative pi over 2. That's right, where is that? Right here. Negative pi over 2, 3/2. That's the same as 1 1/2. So there's that. Then we got negative pi over 4, 0. 0, negative 1 1/2. Pi over 4, 0. And pi over 2, 1 1/2. So there we have one period of our function. Moving on. Vertical shifts. We talked about this a little bit in the last section. It's just moving it up or down, and we call that plus D. So let's look at one with everything in it plus D, plus 1 in this case. And I think my PowerPoint here is missing this 2. There's supposed to be a 2 in front. Okay, so now we're ready. Starting with the amplitude. The amplitude is the absolute value of the number in front, so 2. The period is 2 pi over b. So our period is 2 pi over 2, or pi. And then the phase shift is C over B. And remember, we do the opposite. So we've got positive 3 pi over 2. And then we have a vertical shift, which we can write down. The plus 1 just moves us up 1. Okay, so 5 key points. We're looking at cosine. So cosine is usually at 0, 1. Let's start with our y values here. So since our amplitude is 2, then we would have 0, 2, except that plus 1. It means it's moving our amplitude, which would normally, our y values would look like this. So don't write this down yet. But the amplitude is making everything go, all these y values go up 1. So, hey, let's just leave it like that. Because we'll have to write some more down below anyway. So, making all those go up 1, 2 plus 1 is 3. 0 plus 1 is 1. Negative 2 plus 1 is negative 1. 0 plus 1 is 1. And 2 plus 1 is 3. So there's going to be our y values. Then we talk about our period divided by 4 to get our x values. So the period is pi, so we're going to go every pi divided by 4. So we would start with 0, then pi over 4, pi over 2, 3 pi over 4, and pi. But, of course, we have to add in our phase shift. And our phase shift was to the right 3 pi over 2. So 0 becomes 3 pi over 2. Then pi over 4 plus 3 pi over 2 is 5 pi over 4. And then we can go every pi over 4 from there. So 6 pi over 4 no, let's not do that. We got 5 pi over 4 plus pi over 4. Okay, I messed up a little bit back here again. That's not pi over 4. Okay, so let's try this again. So 3 pi over 2 plus pi over 4 is 7 pi over 4. Add another pi over 4, we get to 2 pi. Add another pi over 4, 9 pi over 4. Add another pi over 4, reduces to 5 pi over 2. Okay, so take our 5 points. And let's graph them. 3 pi over 2, 3. Let's see. 3 pi over 2, if this is pi, and this is 2 pi, and 3 pi over 2 is halfway in between. So we've got that 3. And then we have 7 pi over 4. Let's see, if this is pi, then we've got, that's 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. So 7 pi over 4, 1. 2 pi negative 1, that's easy. 9 pi over 4, just move another pi over 4 over. And then another pi over 4 is at 3 again. So here is what one period would look like. And we could keep going over here just to make it look nice on our graph. There we go. One more example. This time we're going to take a word problem and figure out how we can graph this and how we can write an equation to fit this problem. And we'll look at that more in the next section too, possibly. A region that is 30 degrees north of the equator averages a minimum of 10 hours of daylight in December. Hours of daylight are at a maximum of 14 hours in June. Let X represent the month of the year, with 1 for January, 2 for February, so forth. If Y represents the number of hours of daylight in month X, use a sine function to model the hours of daylight. Okay, so it says, first off, that our hours of daylight oscillate between 10 and 14, a minimum of 10 and a maximum of 14. So if we go over, and I've got a graph over here, our range is only going to go from 10 to 14. So that means that our function has moved from 0 all the way up to 12, because 12 would be in the middle. Normally it would go from -1 to 1, right? Okay? So it's moved up 12 spots. That tells us to start off with that D is 12 because the hours of daylight oscillate between 10 and 14 hours. It's halfway between the two. A, let's see. The maximum hours of daylight are 14 and the minimum are 10. So to get from 12 to 14, you'd add 2. To get from 12 down to 10, you would subtract 2. So the amplitude must be 2. What is the period? The period is 12. And that's just because the cycle is over 12 months, correct? That helps us find B. So we can say 12 equals 2 pi over B, cross multiply, and B is 2 pi over 12 or pi over 6. And then what is C? The phase shift. Whatever the phase shift is will help us with finding C. It says we need to start at the first month whose hours of daylight is 12. Okay, because sine would normally start at 0, 0. We need to start in between. Let's look at the graph a little bit here. So we've got a minimum of 10 and a maximum of 14. We said our amplitude was 2, right? And we need to start the month where we're at 12 because it's going to oscillate above and below 12, right? So if we look back at the problem, it says that there are 10 hours of daylight in December, and in June, there's 14 hours. So we've got December, January, February, March, April, May, June. In December, there were 10 hours, and in June, there are 14. Halfway in between is March. So that means that our phase shift is the distance from here to here, or 3. Our phase shift is 3. That helps us find C, because 3 is C over B, and we've already got B. So C is 3 times pi over 6, or pi over 2. Now we can write our equation. So, y equals A is 2. Then we have sine of bx. So we said b is pi over 6 minus c, which we said is pi over 2. And then we're going, the D is up 12, so plus 12. It didn't ask us to graph this, but let's look at it anyway. So we're starting with 10 hours. It said in December, and then the period it said is it's 12. Kind of hard to do on this graph because I need it marked in 1, 2, 3, 4, 5, not in trig. So it's somewhere around here is 12. Somewhere like that. And so halfway between there and there, it's hard to see. Something like that. So we've got there, and then up, and then down. So there would be 1 year. Okay. And that finally concludes our section on phase shift.